Today's lecture is called How to Solve Any Energy Problem in Physics 111. Any energy problem. I'm going to give you a simple six-step process in which, if you engage brain, really shouldn't be that hard. But you do actually have to visualize what's going on, to picture it and identify clearly. If you just look for letters, you're dead. Well, maybe not dead, but your problem is dead. Your exercise, your answer is dead. Here is the process. What? No, that is the question. Step uno, is it moving? Then there's a kinetic energy term. What's kinetic energy's equation? Half mv squared, okay? And kinetic energy is defined as half mv squared. Know that. Know that. Step dose. Have you gotten high, man? Is it up? Is it above its starting point? Has it gone above somewhere? Is upness happening? If it's up, what kind of energy do you have? Gravitational. Well, there are two kinds of potential that we're going to talk about. Gravitational potential, UG. What's gravitational potential energy's equation? MGH. If you know that, we're most of the way done. Third step, is a spring compressed, extended, springified? Again, that shouldn't be killer. I'm going to give you a new equation today. Do you remember spring constant? Do you remember displacement? Change in length? What's that equation for a spring force? Anyone remember springs? Oh my God, it was last week. Oh, 2 weeks ago. Wait, last week. Crap. When did we do springs? Was it a week ago? Oh, for God's sake. What's the spring equation? Anyone have that to the tip of their head? Kx, to be precise, negative k times the change in length. Don't get that confused with what I'm going to give you. Kx, force, not energy. Force and energy are different things. Also, there's a k in the spring equation. There's a k for kinetic energy. If you confuse those, you're also dead in the water. By context, it should be bleedingly clear. If I tell you a number in joules and say this is your kinetic energy, you shouldn't plug in for spring constant. If I tell you something is measured in newtons per meter, you shouldn't plug that in for kinetic energy. Yeah? So here's the equation. Elastic potential energy set of kx, half kx squared. Bam! Elastic potential energy, half kx squared. That's it. There are only three things. There are only three forms of energy for this class anyway. We're not talking about, there are probably dozens more. We're not going to talk about any of them. You can identify moving up and springified. That's it. That's all you need to do to solve any problem in a third of the final exam. Okay. But again, I've found that this is hard. I'm going to give you some practice problems to see if we can identify moving upness and spring compression and ask you to identify, instead of saying the words, I want you to say the letter. Oh, here's some practice. The letter only, not the word, the letter of the kind of energy. So your answers should have K, UG, or UK in them. Yeah, UE is what I'm calling spring energy. Yeah? K for kinetic energy, UG for gravitational energy, UE for elastic spring potential energy. Okay, great. Let's check on this. Here we go. I've got a roller coaster, and I'm going to describe its motion. Think carefully. A roller coaster is starting from a tall hill. Call them hills, right? High place on the track. It rolls down, gets faster, gets faster, gets faster, goes around a loop the loop. And I will tell you, we did not discuss loop the loops, death loops, whatever, the vertical loops in roller coasters. We didn't discuss those in the rotation chapter, but I will tell you that when you're going around the loop to loop, you can't stop and stay on the loop to loop. You've got to keep moving or you're just going to fall down. Okay, we didn't discuss that, but does that kind of like match with your experience with roller coasters? I want you to identify 3 times. The first time is at the peak of the hill. The second is entering the loop. The third time is at the top of the loop. Okay, so let me sketch this. I like to sketch in blue because do-ba-dee-ba-doo-ba-doo. Okay, so time 1 is up here. That's silly. That's a silly way to write it. Whatever, who cares? Time 2 is down there. Time 3 is up there. And I'm going around, right around the circle. Whee! Can everyone visualize the roller coaster situation? Everyone has seen roller coasters, know what I'm talking about, has heard the words. If anyone wishes for a clarification, please squeak now or forever hold your pee. Speak now or forever hold your peace. Yes. Okay. And so again, we start at rest, roughly, at the very peak of the hill. We go down, we're moving very fast. We go around the circle. We do not stop at the top. And we keep going. Yeah? Do not stop at the top. Using those 3 symbols, really, it's not 3 letters. Using these 3 symbols, K, UG, UE, identify what forms of energy we have at time 1, at time 2, and time 3. So Google question A, what forms of E, I should say at 1. Google question B, what forms of E at 2? Google question C, what forms of energy at 3? Should you tell me the equation? Should you tell me words? Should you write a paragraph? Just the letters, please. What? Oh, hey. What letters did I say are legal? Turn to your neighbor and ask them what letters you're supposed to use. No, I'm calm. I'm calm because I'm just going to give them 0 participation points for completely ignoring the instructions that were said 3 times. I'm calm. It's okay. Okay, 30 seconds left. One more time. What are the three things that you're allowed to type? K for kinetic, UG for gravitational, UE for elastic. Right now I've got about 30 people who are typing other things. I'm no longer frustrated by this. I'm just going to kill all your participation points for the day. If you can't listen to those instructions, you're not listening. Oh, look, threatening you guys got results. Yeah, I should do that more often. Half a second. I'm doing a final count. And half the class. Okay, question. Yes, absolutely. Okay, one more time. One more time. I'm going to describe and then I'm going to give the answers. We start at the peak of the hill, barely moving. I mean, we're not just staying there, but at the peak of the hill, we're not trucking along. I'm saying in order just barely to clear the hill, right? Google, not Google, algorithm step uno, is it up? Yes. Yes, we are up. This is up. Up is this direction. If you did not include UG, reflect on this. If the top of a roller coaster isn't high up, where is? Okay, so UG is an essential part of time one. The second thing, as I described it, are we moving? I would say, as described, no, we are not moving. At the top of the hill, you're barely trucking along, and then you zoom around, right? If we're solving a problem, if we're analyzing a situation, barely moving will have a tiny energy, and you would ignore it. So I should not include K. Finally, is there a spring here? Did I mention anything about springs? Then why are there 20 people saying UE? Where did that come from? There's no spring mentioned. If there's no spring being sprung, don't include a spring term. Okay. Part dose. Let's discuss part dose. We go down the hill. We go fast. I'm assuming no friction. You don't need to assume no friction in this. There could be friction. We could analyze that as a work. I didn't tell you about that, but from what I told you, you go down and you're moving fast. What do those words indicate? You should say that there's kinetic energy, and I would call this at your lowest point, I would call that no gravitational potential energy. I would define your lowest point as your height equals 0. Now, as I pointed out before, actually, your 0 point is a matter of your choice. You can choose any point to be 0 height. But, I mean, come on. At the bottom of the hill, you're at y equals 0, right? That should maybe be a reasonable guess to make. Okay, then, is there a spring? Still no. There's still no spring. I did not mention any spring. There's no spring, so no UE. Third, is there a spring? Still no spring has been mentioned. No spring. Don't include a spring term. The roller coaster is moving quite quickly though, so you absolutely should have included a kinetic energy term. Are we up? Yes, we are positively up. The correct answer for answer C would be kinetic and gravitational potential energy. That is to say, UG, K are the only admissible letters. Turn to your neighbor and discuss. Where is this hard? What am I, where are you breaking here? I have no idea how to draw a bow and arrow. Nah, I'll just be, I'll just shoot a gun in the air. This is a really good idea, by the way. Really good idea to shoot a gun straight up. Straight up. I should, wait, that's a shell. I know that about guns. The bullet is round. Okay, questions, any questions? Squeak now or forever hold your pee. You can't go to the bathroom again unless you squeak. I mean, speak now and forever hold your peace. Please. If there's a spring, if a spring is compressed or extended. If and only if a spring is springifying, springificacious, doing springy thingy. Sure, a trampoline's a spring. In a second, I'm gonna go inside this gun and say, I don't shoot a real gun. I shoot a clown's pop gun with a little spring inside. We'll do that in a second. In a second. Okay, here's the next problem. I shoot a gun straight up, which is a great idea. Absolutely no danger whatsoever in shooting a gun straight up. Call time 1 the instant the bullet clears the barrel. Call time 2 the instant where the bullet reaches its peak height. And call time 3 my last moment on Earth, okay? I hold the gun like this. Pew! Right? Really smart idea. You should do this. Okay, Google questions D, E, and F. What form or forms of energy do I have? Your only legal letters are K, U, G, and UE. Well, letters. You know what I mean. Are we up? Are we moving? Is there a spring somewhere? Time 1 energies, time 2 energies, time 3 energies. Just the forms. I would encourage you, by the way, to think of your lowest point, define your lowest point as y equals 0. I'm just going to say that my head is y equals 0, just for the hell of it. We're only talking about motion at or above my head. I think that's a reasonable place to call 0. Okay, 30 seconds. And again, I'm going to take all participation points away if you do not follow the instructions. I have said like 6 times now about the letters that are permitted. No pity.
Diagram, is it basically all three of them like above?
Where's the spring?
Huh?
Where's the spring?
Oh, in the cocking mechanism, right?
I told you the time one is as it leaves the barrel.
Yeah, I know, I figured that.
No spring.
Huh?
No spring. There's no spring.
So you just said it. What? Huh?
No spring.
Oh, I didn't put a spring in there.
At any rate, where's the energy to shoot a gun come from? Does it come from the cocking that thing? That spring is not where the energy comes from. You have to have gunpowder in a gun, bullet, shell to go. The energy comes from the gunpowder.
I was just saying, isn't it technically all of them like at a like above the Y0 technically? Yeah. Like not even the top.
The energy to go up and down does not come from the hammer. Where's the spring? Can you describe the springs? You said all of them.
I'm talking about gravitational energy.
Yeah, you said all of them, but there are 3. I thought you said spring as well. All of them meaning both of them.
I'm talking about the diagram.
Okay, go on.
Like where you put time 1, time 2, and time 3.
Yeah.
Isn't it technically all above the Y0? So isn't it all of technically?
Well, I defined over here and said that I'm going to say my head, the lowest point is y equals 0. Sorry, I heard, isn't it always all 3 forms of energy? Instead, I was puzzled. It is always possible that there is no energy. You could say none for that, I suppose. Okay, here we go. Ready, set, go. Are we moving? I shoot a gun. Is the shell going, the bullet going anywhere? Yes. There is kinetic energy. Time dose. And that's the only thing. The correct answer is K. That's it. I defined, for the sake of uniformity, I defined y equals 0 at this point. This is 0 height for me. It's the lowest, and it's the lowest that the bullet ever goes from the beginning of the problem to the end of my life. Sorry, I'm getting so super morbid here. I don't know. Okay, so I called this y equals 0. There is no gravitational potential energy at the beginning. I'm as low as I get. Kinetic only. At the peak, am I moving? No. At the peak of my motion, suppose I'm going up, then a second later I'll be higher. That's not the peak. At the peak of the motion, suppose I'm moving down. An instant before, I must have been higher. At the peak of your motion, your velocity is 0. Yes, no kinetic. Correct. Kinetic energy equals 0 at time 2. Okay, so here is a fact. At the peak position, you are not going up or down. Your velocity is at that instant 0. Remember, you are still accelerating, but you are not moving. Remember that velocity is the slope. What is the slope at the peak of a parabola? Horizontal, slope 0, not moving up, not moving down. Take a note on that if you've forgotten it. It'll be useful for the final. So the correct answer for time 2 is UG. Only UG. Time 3. We are still moving. We are not up. There is no spring anywhere mentioned in this problem. Kinetic and only kinetic. So the correct answers for DEF were K, UG, K. Question. As I described it, I want you to talk about the instant before it strikes me, my last moment of life. Not after it has embedded itself in my, I don't know how fast they go, foot, brain, whatever. Oh, of course, I'm Superman before it bounces off my head. The process of embedding, there would be significant other forces that we haven't identified yet. We would have to talk about that as a work done by brain matter. Ew. Okay, this is 2 more, but I want to move on. Pop gun time. No, forget the gun. Forget the gun altogether. I have a springety spring. I have a springified spring. There is a ball inside a tube, and the spring at time 0 is going to release and shoot the ball up into the sky. Okay, so I push the spring down. There must be some kind of mechanism in there to latch it down, put the ball in, and at time 0, release the springs. It springs up and reaches some maximum height. I want you to analyze time 1 when the spring is released. The moment the spring is released. The instant the spring is released. What form or forms of energy do we have? Time h at the peak of motion. The highest point the ball gets. Identify the form or forms of energy. Boing! And to be completely internally consistent, let's call this height our reference level. Again, there are multiple ways to do this, but I'm going to establish that as a convention. I should be very precise. At the instant Again, I'm going to define spring potential energy happens when a spring is extended or compressed. Gravitational potential energy happens when you are up, when something is up. And kinetic energy happens when something is moving. And all points are being taken off for several more students. And I'm going to be okay with that. Okay, the correct answer is at the instant that the spring is released, there is no kinetic energy. No force can give you velocity at 0 seconds worth of time. Remember, change in velocity equals a times t? What if t equals 0? Then change in velocity is 0. If you are not moving at the instant that you start accelerating, no acceleration has gathered together a velocity. So no kinetic energy. Also, as I defined this as our reference height, no gravitational energy. UE. And only UE. Highest point, is the spring compressed? No. Are we moving? No. You're at your highest point. Is there height? You betcha. You betcha. Correct answer for H is gravitational potential, UG only. Only UG. You are up. You are not moving. There is no spring stretched or compressed. Okay. Let's do some canned problems. Again, I want you to here. A half pipe looks like this. Here is skateboarder at time 1. Here is skateboarder at time 2. When I say just make it, I mean if you were going any slower, you wouldn't reach the top. If you're going any faster, well, you have extra unnecessary. I will also point out here that the normal force of the half pipe on the skater does no work because normal is always perpendicular to the direction of motion. So you only need to consider the forms of energy that we've talked about, not work done by extra forces. Call this time 1, call this time 2. And why not? Let's define y equals 0 not at the initial time, but at the final time. Google question I. What form of energy, just the kind, not the number, at time 1, J. What form at time 2, K. Solve, find amount of energy. Right? Why not? Okay, JKL, find the initial. Questions, questions, questions. Please. Yes, absolutely. Kinetic, can't. Spring, can't. But you can be in a hole. Exactly. Y can be negative. If you're not moving, what would make you go up? Yeah, but I'm saying that if you're just trying to coast all the way up, how fast do you need to be moving at the bottom if you're going to just barely reach the top? If you're not moving at the bottom, you're never going to hit the top. Look carefully where I've defined y. Remember what I said, gravitational potential energy is defined relative to your your reference point. Kinetic energy is defined relative to your reference. Look how I've defined my reference. Up and down refers to compared to somewhere. In the previous problems, I was saying relative to initial. Here I'm not. Where's this? Du más minutos, 2 Minuten, da. 2 minutes. What, you don't speak da? It's Morse code. I'm just being silly, as usual. I'm such a big silly. You speak what? Mug? The language of all-nighters? Oh, coffee. Coffee mug?
No, I said from a game.
Oh.
I can speak it.
You're not bullshitting me? That's
No,
actually a language?
I was saying like in the fields of hope that we find past darkness.
That's pretty damn cool. You're a big nerd, which is a compliment in my language. Okay, time's up. As written, the correct answers are UGK, none, roughly 1,600 joules-ish, and 7.7 meters per second. I want to talk about that. That's going to be a big discussion. We're going to talk about why people who didn't put that still got the answers right. Talk about that in half a second. But first, I want to see if there are other questions. That is the center of where I'm going with this. No other questions? Yeah, please. That's what she said. And that's what I'm going to go. Yeah. What do you mean? Say more? Oh, question K. Find the total amount of energy. Yeah, absolutely. We'll do it. I'll solve it in 2 seconds. Okay, so first off, I want to make the big dealio about the kinds of energy. As I described it before, kinetic energy, are you up relative to some defined point? Usually I will call ground level zero potential energy. Hey, but what did I do before when I was shooting myself in the head? I said my head is zero height. I am the center of the universe was my assumption, which, being a professor is what I believe. The other time, the bottom of the railroad track. Oh, well, that one was shown at the bottom. We did a third one. What's the third one? The spring. Okay, you could say at the bottom of the tube is zero, but I said the initial position of the compressed spring, where the ball starts, is zero. It doesn't actually matter, we'll see in Two Shakes of a Lamb's Tail, it doesn't actually matter for the final equation, but as defined, if I say that this is my reference height, when I am at this height, mg times y, mg times what's y here? Zero. If I say gravitational potential energy is mgy, and I'm at where y equals zero, gravitational potential energy is zero. What's my gravitational potential energy down here? Negative. Y is negative. I am below. So if I wished to write this out as an equation, and of course everybody wishes to write this out as an equation, I would say my initial energy is kinetic plus gravitational potential energy, and this term is going to be negative. At time 2, I'm not moving. I'm at where I've called zero height. I claim conservation of energy that this is equal. Let's write down a mathematical statement that says that the initial total energy equals the final total energy. Okay. Well, I've got m, but who cares, right? Who cares? I don't need m. M cancels. Divide both sides by m. What's 0 over m? So I then have, let's see, g. Oh, I've heard a rumor about what g is. Oh, and I can add 3g to both sides, right? G times negative 3 is minus 3g. You okay with that? And then I substitute in a value. Oh, for God's sake. When I was speaking out the answers, I spoke incorrectly. As defined, zero total energy. The initial energy has a plus part and a minus part. The final energy is zero. Like that. I mean, that's that. And the final is that. So I'm saying initial equals final. That's conservation of energy. That's what I mean by energy is conserved. The initial equals the final. Unless you have an external force doing work, but we don't here. Okay, now I want to think about what if instead of saying that this is zero height, we said that this is zero height. What form of energy do I start with? All kinetic, because I'm at my reference height. And then the skateboarder gets high, man. Initial kinetic turns into final gravitational. Wait, hold on. This time UG was negative. This time UG is positive. If I have the statement, if I have this statement, how different is that from saying that? I've just shifted one of the terms over to the other side of the equation. I have interpreted it in a different way, but you have to get the same answer. As I claimed before, your reference point is actually unknown and unknowable. Once you define it, you have to be consistent. But once you find it, the answer is the answer is the answer. Your velocity cannot depend on the means you use to calculate it. In this case, half mv squared works out to be 1620 joules. This way of thinking about it. Question me. Yeah. Bitte. Other questions? Okay, what we've been doing here is to say that once we find the individual forms of energy, the total energy is add them together. I mean, kind of duh, right? Total just means sum of the individual parts. What if I give you two different times? Well, you could find the initial total and the final total. Now, in all of what we didn't have external forces that we didn't calculate with. I mean, there was a spring force, sure, but we already accounted for that. There's a gravity force, sure, we already accounted for weight, right? If there are other forces that are doing work, calculate the work done. Yeah? Work changes energy. If I've already accounted for spring force, if I've already accounted for weight force in the potential energy terms, don't double count them, but every other work that applies, calculate them. And here is the one and only equation I claim that is a physics idea. Everything else is a definition. Work equals force displacement, cos theta, that's the definition of work. Half mv squared, definition. Half kx squared, definition. Mgh, definition. This is the only idea of physics that is what? The only idea of physics that is a theory, that is a connects definitions with real predictions. What happens if I subtract initial from both sides? What do you get? Delta E. What's on the right side? Work. Change of energy is equal to work done. You are free to write it either way. You could free to write it either way. Work equals change in energy. Final equals initial plus work. Here is my patent pending process for solving any problem whatsoever, any physics problem. I suggest you use different methods when approaching your relationships. Thank you. You get an A. Jawohl is good. Make sensey? Clicky? Let's do one more. I'm not going to scaffold you this time. Yeah? Here's the work. There's a work going on here. And I just want you to identify forms, by the way, and I'm giving a hint that there's a work done. The work done by, oh God, what is the work? Work done by normal force, I guess. I think. And the ball is springy too. So I want you to tell me former forms of energy. And let me sketch it. Let's see, I drop it from here. This is the 2.5 meters he's referring to. The instant it strikes the ground is when the bottom fuzz touches. Oh God, it's fuzz. But bouncing things act like springs. Bouncing springs compress, they pancake a smidge. Balls don't actually stay perfect spheres when they are bouncing off. I mean, like I just said, they're kind of springs. So this here, the ball compresses by about 6 millimeters. Actually, a fair amount. That is referring to from the middle here to the middle there. Its lowest point. The lowest center. And then it's moving upward, springing off as the bottom fuzz leaves contact with the ground it's going there, and then it goes up to some final height. We've got theoretically 20 minutes, but I'm not going to put you through all that. I'm going to put you through 5 parts. I need to define zero height. I'm going to say y equals 0 is not the surface of the tennis court. I'm going to say y equals 0 is 1 ball radius. How big are your balls? That's how where y equals 0. Okay. Oh, we've got 20 minutes. You could do this. You're just naming things. M, N, O, P, and Q. Former forms of energy at time 1, 2, 3, 4, 5. I mean, kind of duh, right? And if there is a work done, which there is, the ball doesn't get up to the same height, you should know that final energy is not equal to initial energy here. Final energy would be initial energy minus the work done by the normal force as it I guess as it absorbs some of the springiness. It's not perfectly elastic. Two is the instant the bottom fuzz touches the court surface. 3 is this pancakes a little, not much. Squishes a little bit, it reaches rest. 4 is it's re-expanding. This is how bouncing happens. If you have a high-speed camera, you can see this. Well, like with the tennis ball, yes. With a dodgeball, yes. With a cue ball, not so much. 4 is it's moving upward, but its center, it's just barely leaving the ground, moving up. And 5 is at its final height. Note, while I'm saying there's work being done, how do I know that? Because it starts from a height of 2.5 meters and it ends at a height of 1.4 meters. Something had to suck energy out of it. Where does it go? Work is not a form of energy. Work is not a form of energy. I want you just to tell me energy total. Energy will change because of work. You would add or subtract. That doesn't mean work is energy.
spring? No.
It's moving. It's moving at the instant it touches. The fuzz touches. The bounce process.
Is that all?
When the fuzz touches, it does not instantaneously stop. Good. Look very carefully at where I defined y equals 0 is also potential at time 3. There is a y at that time. It is pancaked. The center of the ball is below the origin. Position origin.
At least what I was thinking.
At time 3, question O, it is actually still not, the center is not at the origin.
That implied still moving then?
No. UG.
Oh, I don't know why I said the opposite when I was actually thinking. I don't know why I said
Good.
that.
And at the beginning, the instant you drop something, how fast is it going?
It would be the initial.
The instant you drop something, I call dropping something instead of throwing something. Dropping, releasing,
Just the
0.
motion of doing this.
There is no motion of doing that. The instant you stop holding it, it is not moving. Whenever we say released from rest, dropped, there's another key word. You can take that to mean initial velocity 0.
First drop to have.
Correct. It is not moving at the instant you release it. There's been no time for gravity to accelerate it.
Okay. 4 magnetic energy.
You betcha.
And then I think he was blocked because of the fill out response thing. Just, I think, sure.
At the highest point at the end, the ball, the height to which you rebound. When you are at your peak height, are you moving?
So I guess just like visual example, if it's like peak, it stops and then
If it stops, is it moving?
it's not. My thought process was it was gonna like almost instantaneously move again. Like if it reaches peak, it's gonna instantaneously move again. so
It
there's still
will be moving, but consider this. Velocity's got to be positive, negative, or 0, right? If you got positive velocity, you're moving upward. An instant later, you'll be higher,
Yeah, right.
right?
Yeah, I'm listening. It's just that's kind of
So an instant later, you'll be higher. If you are going higher, then you're not at your peak yet. Consider if your velocity is negative. An instant earlier, you must have been higher for velocity to be negative.
I think that's the answers already. I just want to make sure I understand. This is correct, right?
Yeah.
So in that case, I just think a keyword in it. Okay. I guess I think I'm mixing up a lot of things like kinetic energy. I just think kinetic energy is used more than it actually is. That's probably one thing I consider it.
Let's see if I'm correct.
I think I should answer it. I think we're low on time. Scroll down. P, no elastic energy anymore. Once the ball is not compressed, pancaked, is it intense? Glad I brought my jacket.
Yeah. But, for 2, potential is there.
Oh, 1 and 2 are fine.
Okay.
I think 3 is fine. 4, I'm saying there's no
The
springness.
The spring's been thrown. Okay, that makes sense.
It is returned to round.
Makes sense.
Okay, time for the answers. And then I'll let you guys go get soaked. And me soaked too, for that matter. I'm high. Gravitational potential, UG. I'm not moving. Shh. I can let you go in 2 seconds. Shh. I am high. I'm not moving. I am not stretchy compressy. UG only. I am at my 0 point. No UG anymore. I've defined when you are at 1 ball radius above the tennis court. When the bottom fuzz is just barely touching, the center of the ball is at y equals 0. No gravitational potential energy. But I have not reached my lowest squish. I'm still moving. The instant the fuzz touches the ground, the normal force of the ground on the ball has not had a chance to slow it. At that instant, delta V is 0 because t equals 0. Okay, so the correct answer for 2 is kinetic energy only, K only. 2 is K. No, 1 is just UG. It's not moving the instant you release it. Gravity hasn't had any time to accelerate it. 3, it has reached maximum squish, just like my wife and I. After 24 years together, we cuddly. UE, it is at its maximum squish, no kinetic. But my center is not at the 0 point. There is also UG. 4, I am moving up. I am not squished. I'm at my 0 point K only. 5, UG only. Questions? Yes. If you reach your highest point, are you moving? V equals 0, kinetic is 0. Adios, everybody. I love each and every one of you. See you Monday. Unless the classroom burns down from the lightning.